For 31 years, I paid climbing electricity bills and endured unreliable service without question. I just assumed this was how life worked. You pay, you hope the power stays on, and when it doesn't, you deal with the consequences. Then came the blackout that broke me. My freezer held $400 worth of venison and beef. Meat I had hunted and butchered myself. Months of work and planning sitting in that chest freezer. When the grid went down and stayed down, I watched every dollar of it rot. The grief was real, but the anger, that was something else entirely. Because this wasn't a natural disaster. This was a system that took my money every single month and still couldn't keep my lights on. So I did what any reasonable person does. I started researching solutions. The solar industry was happy to help. They pointed me toward lithium battery banks, sleek wall-mounted units that looked like something out of a spaceship. The pitch was compelling. The price was not. $40,000. That's what energy independence was supposed to cost. And buried in the fine print was a detail the salesman never led with. Those batteries have a lifespan of roughly 10 years. After that, you're not sitting on an investment. You're sitting on an expensive pile of trash that's remarkably difficult to dispose of responsibly. I walked away. Something about paying $40,000 for a decade-long rental didn't sit right with me. A few months later, I was talking to my friend Harlan, the kind of guy who's forgotten more about practical living than most people ever learn. He mentioned something that stopped me cold. He'd been spending time near an Amish community, and he'd noticed something that didn't make sense to him at first. These families had no power lines running to their properties, no grid connection whatsoever. And yet, refrigerators ran. Power tools operated, lights worked. No utility company, no monthly bill, no lithium wall costing the price of a new car. I needed to see this for myself. So we drove to Lancaster County. I don't know what I expected to find when I followed Harlan down into that basement. Some complicated maze of panels and wiring, maybe. A room humming with expensive technology. What I found instead was almost peaceful. There was no lithium battery bank, no elaborate solar array controller, no wall covered in blinking indicators telling you the system's status. There was a steel wheel, turning slowly and quietly in the corner, like a sleeping cat, completely at rest, doing exactly what it was supposed to do without drawing any attention to itself. It had a presence that was almost calm, unhurried, confident. I stood there for a long moment just watching it spin. Then Harlan told me what this system cost to build. Less than an old used pickup truck. Not a brand new truck, a beater, the kind you'd find on a rural property used for hauling firewood. And this system, cheaper than that, was powering an entire home through the night consistently, without interruption. Without a grid connection, and without a battery that would need replacing before your kids finish high school. 31 years of rising bills, $40,000 solutions that expire. And the whole time, a quiet steel wheel in a Lancaster County basement had already solved the problem. That was the day I started paying very different attention. What is a flywheel? The concept is almost elegantly simple, which is part of why it's so easy to overlook. A flywheel is a heavy, spinning mass, typically a precision-engineered steel wheel, that stores energy in the form of kinetic motion. You spin it up, and it wants to keep spinning. Physics does the rest. Here's how it works in a home energy system. During daylight hours, your solar panels feed energy into the flywheel, gradually bringing it up to speed. The wheel stores that energy, not in chemicals, not in volatile compounds, but in pure rotational momentum. Then when the sun goes down and your panels go dark, the flywheel doesn't stop. It keeps turning, and that turning motion drives a generator that produces steady electricity through the night. No chemical degradation, no charge cycles eating away at capacity, no hazardous materials. Just a wheel doing what wheels do, spinning. This isn't folk wisdom or backyard experimentation. The most advanced aerospace agency on the planet looked at this technology seriously. In 2004, NASA Glenn Research Center published findings from their flywheel energy storage program. The numbers were difficult to argue with. A flywheel system tested through 100,000 complete charge and discharge cycles and held up. For context, a standard lithium battery bank, the $40,000 kind the solar industry wants to sell you, begins meaningful degradation around 4,000 cycles. That's not a minor difference. That's a gap so large, it reframes the entire conversation about what long-term energy storage actually means. NASA wasn't testing this for novelty. They were testing it because the physics worked and they knew it. But NASA wasn't the first institution to reach these conclusions, not by a long shot. In 1978, Sandia National Laboratories, one of the most respected government research institutions in the country, completed a comprehensive study on residential energy storage. Their findings were unambiguous. Flywheel technology was 8 times more efficient and significantly cheaper than the battery-based alternatives being developed for home use at the time. 8 times, for residential applications specifically. The report was thorough, the methodology was sound, the conclusions were clear, and then the report quietly disappeared from public conversation. It wasn't dramatically destroyed or loudly banned. It was something more subtle and more effective. It was simply never discussed, never promoted, never integrated into the energy policy conversations that were actively shaping what Americans would be offered as solutions for the next 5 decades. It sat in archives, while an entirely different industry was built around the technologies the report had just outperformed. Harold Bronner, a former energy policy consultant who worked adjacent to these discussions in the late 1970s and early 1980s, has spoken about what happened in the period following the Sandia findings. According to his testimony, the decision to redirect residential energy storage development away from mechanical systems and toward electrochemical batteries wasn't accidental. It was deliberate. And embedded in the regulatory frameworks that emerged during this period was a specific technical threshold, 50 kilowatts, designed with particular precision. Why 50 kilowatts? Because it placed flywheel systems of meaningful residential scale just outside the range of straightforward civilian implementation. Below that threshold, the permitting landscape was navigable. Above it, or operating in certain configurations near it, the regulatory friction became substantial enough to deter ordinary homeowners from pursuing the technology independently. The threshold wasn't arbitrary. It was architecturally designed to ensure that the average citizen couldn't easily benefit from what the Sandia report had already proven worked better. Perhaps the most telling moment in this entire story didn't come from a government document or a NASA laboratory. It came from a conversation in Pennsylvania. A Penn State-trained mechanical engineer, someone with formal credentials and exactly the kind of systems analysis that should make him skeptical of simple solutions, visited the same Lancaster County community and examined the flywheel systems the Amish had been quietly running for years. His assessment was straightforward and, coming from him, remarkable. He stated plainly that the Amish-designed flywheel configuration would embarrass any major battery manufacturer if the two were placed side by side in an honest comparison. Not because the Amish had access to superior materials or advanced manufacturing, but because they had preserved and refined a mechanical principle that the mainstream energy industry had spent 50 years pretending didn't exist. No marketing budget, no venture capital, no lithium supply chain, just a deep understanding of how a spinning wheel stores energy and the patience to build something that actually lasts. The engineers knew. The government researchers knew, and for nearly half a century, the rest of us weren't supposed to find out. Not everything worth knowing gets published in a journal or filed in a government archive. Some knowledge travels differently, passed from hand to hand, kitchen table to kitchen table, father to son across generations. In 1954, a man named Bishop Daniel Byler sat down and wrote out, by hand, everything his community had learned about mechanical energy storage for the home. The document wasn't long, it wasn't formatted for academic review. It was written in the plain, precise language of a man who wanted practical knowledge to survive him. He titled it Practical Mechanical Storage for the Plain Home. For 50 years, that handwritten manual moved through families without ever being printed commercially, without ever appearing in a catalog or a library system. When a young man set up his first household, an elder handed him a copy. When a neighbor's system needed adjustment, the relevant pages were shared. The knowledge stayed alive not because an institution preserved it, but because the people who used it understood its value and treated it accordingly. That manual is the foundation of everything that follows. Early flywheel systems worked, but they had a problem that became apparent over time, particularly in residential foundations, not built to industrial specifications. A single spinning flywheel generates what engineers call gyroscopic precession, a subtle but persistent wobble produced by the rotational forces acting on the wheel as the earth moves and the surrounding structure flexes. Over months and years, this wobble transmits stress into whatever the system is mounted on. Basements developed hairline cracks. Mounting bolts worked themselves loose. The system remained functional, but its relationship with the building slowly deteriorated. Bishop Byler's manual addressed this directly, and the solution was both simple and elegant. Mount 2 wheels and spin them in opposite directions. When the gyroscopic forces of one wheel push in a given direction, the counter-rotating second wheel produces an equal and opposite force. The two effects cancel each other out almost entirely. The result is a system that sits on its foundation, with remarkable stillness, no transmitted wobble, no progressive cracking, no mounting fatigue. This is the double wheel stack, and once you understand the physics, you wonder why anyone ever built it any other way. 7 years after Bishop Byler wrote his manual, a craftsman named Mervyn Stoltz made it better. Working in 1961, Stoltz wasn't satisfied with simply canceling the gyroscopic wobble. He wanted the two counter-rotating wheels to do more than neutralize each other. He wanted them to actively cooperate. Through careful experimentation with disc geometry and the precise spatial relationship between the two wheels, he developed what he called the twin disc design. The configuration he arrived at didn't just eliminate the wobble problem, it created a subtle aerodynamic and mechanical interaction between the two spinning masses that increased the system's overall energy retention efficiency by 12%. 12% sounds modest until you calculate what it means over a night of power generation. Multiplied across every night of a year, multiplied across the decades, this system will run without replacing a single major component. Mervyn Stoltz, working without a university laboratory or a government grant, added a meaningful and lasting improvement to a technology that the mainstream engineering world had already decided to ignore. His twin-disc design is still the standard in Lancaster County today. Here's where the practical reality becomes almost difficult to believe, not because it's complicated, but because it's so straightforward. A fully functional double-wheel stack home energy system can be built for between $1,800 and $3,000, depending on what you source and where. The core components are not exotic. The motor comes from an old treadmill. Treadmills use surprisingly robust DC motors designed for continuous operation under load, exactly the performance characteristic you need to spin a flywheel up to operational speed and hold it there. They can be found at yard sales, on secondhand marketplaces, and in the back corners of garages across the country for very little money. The flywheel mass itself is fabricated from a steel drum sourced from a scrapyard. The weight and diameter specifications in Byler's manual are achievable with standard scrapyard steel, cut and balanced with basic tools. The foundation and housing use poured concrete, inexpensive, permanent, and more than adequate to anchor the system and provide the thermal mass that helps stabilize. Operation across seasonal temperature changes, no proprietary components, no specialized supply chains, no manufacturer you're dependent on for replacement parts. Every piece of the system can be sourced, replaced, or fabricated by someone with ordinary mechanical competence and a modest budget. This may be the most important practical distinction between a flywheel system and every electrochemical alternative currently being marketed to homeowners. Once a year, you grease the bearings. That is the maintenance schedule. One task, once annually, using standard bearing grease available at any hardware or automotive store. The annual cost of keeping the system in optimal operating condition is approximately $23, not $23 per month, $23 per year. There are no cells to monitor for thermal runaway, no charge management systems to update or replace, no degradation curve to track, no capacity percentage slowly ticking downward year after year. The steel wheel does not care how many times it has spun. It will spin the same on its 10,000th cycle as it did on its first, provided the bearings are kept lubricated. This is what genuine long-term reliability looks like. Not a warranty, not a replacement program, just a wheel turning year after year, decade after decade. I want to be clear about what this is really about, because it's easy to frame this entire conversation in terms of dollars saved and bills reduced. And yes, the financial case is real and it is significant, but that's not the heart of it. The heart of it is a question that a blackout forces you to ask yourself in the dark, standing in front of a freezer full of ruined meat that represented months of your own labor. Who controls whether your home has power tonight? For most of us, the honest answer is uncomfortable. A utility company controls it. A grid infrastructure controls it. Weather events, equipment failures, corporate maintenance schedules, and regulatory decisions made in offices we'll never enter. These are the things that determine whether our homes function. A flywheel in your basement changes that answer completely. When the system is running, the only forces that govern your energy independence are God and the weather, the sun that charges your panels during the day, and the physical laws that keep your wheel spinning through the night. No company, no bill. No outage notification sent as a courtesy while your food spoils and your family sits in the dark. The Amish communities of Lancaster County didn't preserve this technology because they were backward or resistant to progress. They preserved it because they understood something that 50 years of energy industry marketing has worked very hard to make us forget. True independence isn't a product you can buy. It's a system you build and own and maintain yourself. Answerable to nothing and no one except the turning of the earth. That is the formula. That is the freedom. And it costs less than a used pickup truck.